Okay, we already learned how to do the dimensionality reduction. Okay. You know that we want to reduce the column. So the first reduction we learn is we call it data reduction, dimensionality reduction. Now we are going to learn a new data reduction technique. The second one is numerosity reduction. The numerosity, sometimes we call it instance selection. So we want to reduce based on we want to reduce the data volume. If we have 5 data, we want to reduce it into 3. Because this is, we want to make a smaller forms of data representation. There are 2 ways. There are 2 methods. The first method is parametric method. Parametric, we call this is parametric because there are some parameter. Okay. If we have parameter, we call it parametric method. So in this parametric method, we assume that our data fits to some model. What is the model? So for example, do you know regression? So this is one example of the model. If you have the model, you can estimate the model parameters, and then you can store only the parameters, and then you can discard the data if the data is not in the parameter range, except the possible outliers. So we can reduce with these parametric methods. Another example, we call it log linear models. So it will obtain a value at a point in M dimensional space as the product on the appropriate marginal subspaces. So I will not discuss more in details about the log linear models, but at least you know that this log linear models is similar with the regression, but the numbers, you will move it to log function. The second method, we call it non-parametric. So non-parametric, there will be no parameters. No parameters means we do not have any model. Do not assume model. And we can do something like histogram. In the histogram, you can define the bin. Okay. Later we will learn about clustering in the separate section, not now. Or we can do sampling. Okay. So we will learn what are sampling. In the linear regression, in the parametric data reduction, we call it this is parametric because we have the parameter. There are some variants for the regression or the parametric. Here I give 3 examples, regression and the log linear models. So in the linear regression, we have like this function. Y equals to Wx plus B. So this is a regression. We have 2 regression coefficients. The first coefficient is W, and the second coefficient is P. So P is the bias or the error. It specifies the line and are to be estimated by using the data at hand. We will use the least square criterion to know the value of y. Least squares criterion. We want to reduce the errors. We want to check which are the least errors. That's the least squares criterion. Multiple regression. If we are dealing with the linear regression, usually we say that we have one variable and one target. The variable is x, and then the target is y. So one variable and one target. Usually we call it, this is the simple linear regression. We can have another variant, we call it multiple. We call multiple because we have n variables. N variables means, yeah, we have many variables, and we will have one target, or we have multiple x, x1, x2, x3 until xn, and we have one target which is only y. That's why the equation is something like this one. Y equals to b0 plus b1 multiplied by x1 plus b2 multiplied by x2. We can have non-linear functions. If it is linear, then we will have only x, okay, like this one, x1, x2, and we will always use plus. But if it is non-linear function, we can have y, for example, b0 plus b1 x1, maybe we have b2 x2 power of 2. So there's a quadratic, or there can be another function like b3 with cubic. So the cubic means we will have the power of 3 and so on. So it is non-linear. Log linear models. In the log linear models, we approximate discrete multi-dimensional probability distribution. So we also have similar way like this y equals to b0 plus b1. We will do some log function of the x1, or we will have also b2, and we will do the log function of the x2. So we call this is the probability distribution with the log function. And it estimates the probability of each point tuple in a multi-dimensional space for a set of discrete attributes. Sometimes we can have another way to deal with these log linear models. So there are several variants of the log. We can have also the log function of y. So the y will be logged first before we make it as a target. It is useful for the dimensionality reduction and data smoothing. Yeah, I just give you a review for this log linear. But the most important thing is the regression. People will use this regression to analyze two variables. Okay, now we have the simple regression. The regression analysis, it is a collective name for techniques for the modeling and analysis of numerical data. Okay, we will have the X is numerical and Y also numerical. We have dependent variable or response variable or measurement, and one or more independent variables. We call it explanatory variables or predictors. So if you look at the many functions in the regression, we have x, y plus equals to, maybe we can say b0, or sometimes we call it a alpha plus the wx1, this is to weight 1, plus wx2, plus wx3. We call y as dependent variable, and we call x1, x2, x3, they are the independent variable or explanatory variables or predictors. The parameters are estimated so as to give the best fit of the data. Let's say if I want to have like this function, how can we get this line? How can we obtain the line? The best fit. What is the best fit? So we want to see the least square method. The least square method means I want to see whether the data with respect to the line is having a small error or not. This is what? If all data have the smallest error, then we will use this line. So that's why usually this kind of line you will check. It can be this line or it can be this line. So we will check every possibility, and this will be the least error. Least error means the smallest errors. Okay. This is the least square method. We want to see the smallest error. Usually we use this for prediction, including like the forecasting time series data, inference, hypothesis testing, and modeling causal relationship. We will learn more about this histogram analysis. I think you already know with the histogram, we are going to plot the numerical data. The X will be numerical data, and the Y will be the frequency. So based on this number, I can see that the range of numbers between 0 until 10,000, there are like this frequency. The range of this from until this one, there are this frequency. We call this one as the histogram, and we can divide the data into buckets. I think last time you learned about bin. Okay, bin is one bucket. Second bin, the second bucket, we have another bin. And we can store the average or summation for each of the bucket. So if we are dealing with this one, then we want to summation. We want to check the frequency. Or you can also measure the average and etc. You already learned the rules like equal width and equal frequency. Okay, last week we already learned this one. Clustering. Clustering means we want to partition the data into clusters. What does it mean by clusters? We call it group. We want to make groups, some groups based on the similarity. So let's say you are the student of Hanguk Vede. So we can be in a group. If we meet students from other university, then they can be another group. So we are similar because we are from Hanguk Vede Dongin campus. And we can save, we can store cluster representation, maybe centroid or diameter to represent this group. Can be very effective if the data is clustered, but not if the data is smeared. You know, by smear, we call it smear is dirty. For example, do you know the face recognition? There is a technology for face recognition. If you look at this face, it is not a common face because there are many dirty areas. Okay? Like this one, dirty, dirty. So we cannot make a good cluster if the data is dirty. So there are many choices of clustering definition and clustering algorithms. The cluster analysis will be studied later. So using the clustering, we can reduce the data. Okay. Let's say if we have the cluster, we have the group. Okay, I will just use the centroid, the center, or I will use the diameter only. Then we can just have very small data. Sampling. When we do sampling means we want to obtain a small sample S to represent the whole data set N. I have N, but I just want to do sampling and we call it S. So I forgot the Korean name, but you know if you do the election, okay, to pew. So if you do the election like the president's election, if you need to wait the whole result from the Korean population, you need to wait until 1 day or maybe a few hours. So they have the quick count. What is the quick count? Just select only several people from certain region and then they calculate what is the possibility one candidate wins and what is the possibility one candidate lose. So the quick count is based on the sampling. They know how to do the proper sample, so the result of the quick count will be similar to the election. So we need to use this sampling because we can allow a mining algorithm to run in complexity that is potentially sublinear to the size of the data. So when we do sampling, of course, we will have faster computation rather than the complex computation. The key principle is how we can choose a representative subset of the data. The simple random sampling may have very poor performance in the presence of skew. And we can adopt some adaptive sampling methods like stratified sampling. So there are several types of sampling that we can learn. Simple random sampling. So there is an equal probability of selecting any particular item. This simple random sampling, yeah, we just choose anything. Maybe from this population, I need to choose 5. Then I will choose, yeah, random. Just random, and we have some probability to choose this random. We have another way of sampling. We call it sampling without replacement. Once an object is selected, it is removed from the population. We have another sampling method. We call it sampling with replacement. A selected object is not removed from the population. It means the object can be pre-selected, because once we select an object, we can put it again in the population. So if we select randomly, we can select again that from the population. Stratified sampling. We will partition the data set and then draw samples from each partition. So proportionally, approximately the same percentage of the data. So let's say I have this light blue and then I have this dark blue. So if I do the stratified sample, so I will just proportionally from this and from this. But if you use the simple random sample like this one, we just select and we do not care whether they are in the blue or they are in the light blue. But here we first distinguish. Then this class we will take 2. This class we will take 3. So we call this the stratified sample. And we hope that with this stratified sample, we have the same percentage of the data. So this is an example. Simple random sample without replacement. If it is without replacement, then once it is selected, it is removed from the population. So white is selected. Once this is selected, then okay, there will be no of this data. There will be no this data in the population. And once we get this one selected, then okay, it is removed from the population. But the simple random sample with replacement, we can select the same object again, because after we take this one, we can put again in the population. That's why there will be a possibility to select this one again into the sample. Yeah, if we have the clusters, for example, I know that my data, or this is the raw data, can be clustered or can be grouped into this light blue, dark blue, and white. So with this stratified sample, or we call it, this is cluster sample. Okay. Sometimes we call it the cluster sample, sometimes we call it with the stratified sample, but actually there is a little bit different. If we use the cluster sample, so we can make 1, 2, 3, 4, 5, for example, we have 5 clusters or we have 5 groups. And then among the 5 groups, we just select 2. Maybe we have 3 clusters like this one. We want to select only 2, so we select 2. Or we use the stratified sample, like what I mentioned before. We select every object from the group. So we just select only 1, 2, 3, 4, 5 among the existing data. Here we select only 4 data among the existing data. So this is the numerosity reduction. We want to reduce the data based on the sampling. Sometimes we can also do the data reduction with aggregation. Aggregate. This aggregation means we want to aggregate the data for individual entity of interest. Let's say I have this sales data cube. Okay, we call it data cube. Cube is a small, because this is cube. And I have this cube with regard to time, location, items. So you can see the time. This is the Q1, the time. Location. Location is this city, whether it is Chicago, New York, Toronto, and Vancouver. And an item. I can have the item, whether it is home entertainment, computer, phone, or security products. If we look at this number, it means we have 605. So this 605 means there are 605 sales in the Q1 in Vancouver with the product home entertainment. So it is only one cube. 825 means it is a sales on the Q1 in Vancouver and the product is computer. So we will separate it based on this cube. If you want to make the data reduce, you can select maybe some of the particular cube. You don't need to select all the data. We can have multi-levels of aggregation in data cubes. So further reduce the size of the data to deal with. For example, maybe on the first time I have this data. I have all data January, February, March, April, May, June, July, all of the months. But within that, okay, it is too much. I do not want to use all the months. Then I can aggregate it. This January, February, or March, we can call it as the Q1. So it means I can reduce 3 data into 1 data, which is Q1. We can have reference appropriate levels. It means we can use the smallest representation, which is enough to solve the task. Basically, this is very depending on your analysis later. If you are going to predict the next quarter, then you can use the quarter-based data. If you want to predict the next month, of course you need to use this month. But this kind of aggregation is an alternative to reduce the data. Okay, we can select, you can check on the orange. Let me just use this iris step, okay, for our example. And we can select rows. We can select rows because maybe we think that the number of rows are a lot. So we can just select only the important rows. So when we select the rows, there are some options or there are some conditions. Maybe you want to choose only the iris, which is setosa. Okay, so it means you just select only the particular class. And maybe you want to make another condition. Let's say I want to choose only the septa length, which is, you can select this operator, whether equals, is not, or is below, is at most, is greater than, and so on. Let's say I want to choose the septa length which is greater than 2.5, for example. Then you can make a data table. This is the iris setosa data, which have the septa length higher than 2.5. So we can get 50 instances. 50 instances. So you can look at the original data before you select the rows. Okay, the original data, we have 150 instances. So after we select the rows, which is iris setosa, and the septa length is greater than 2.5, then it is reduced. We can get only 50 instances. Okay. So this is manual. You will have the condition. You can also do with the linear regression. Okay. Maybe this is not a good linear regression, but let me just show you. First, we can select the column. As I mentioned to you, when we do the linear regression, we have the y, and then we need to define, they will calculate the alpha or the beta 0 plus the weight of variable 1. So we need to define what is the y and what is the x. In this case, I would like to select the column because it is linear regression. As I mentioned to you, it should have 1 target, which is numerical. Okay. And at least we have one variable, and it is also numerical. So I will change the target. In this case, the target is still iris. What is the data type? It is categorical. So it is not good for the linear regression. And we will change this one. I will remove, and then, for example, this is just example. Okay. Can I predict the sepal length if I know the sepal width, petal width, and petal length? Maybe in order to make a very simple one, let's just use one variable. If I know the sepal width, can I predict the sepal length? Okay. So I can use this one with the linear regression. Okay. In the linear regression, we will have many options. Okay. But I do not want to discuss the regularization. There will be the Ritz regression, lasso regression, and elastic net. Let's just use the common one. There's no regularization. And if you want to see the result, actually we can do with the data table. So this is directly the result of the linear regression. It means we have y. Y will be intercept. This is 6.84122 plus minus 20887 x1. So this is the function of the linear regression. So if you want to get the set file, if you want to get the sepal length, so the sepal length can be predicted if I know the sepal width, and it should be multiplied with the minus 0.0. And based on this data, this is based on the linear regression. So you can reduce the data based on this function. Or you can reduce it if you have this scatter plot. So the sepal width and the sepal length. And then if you can show the regression line, yeah, something like this one. Because the weight is negative, so that's why the R value is negative. So maybe you say that, okay, I do not want to choose the upper side, and I do not want to choose the lower side. So in this orange, you can select the data. Let's say I just want to select from this range until this range. So you can plot manually like this one. And the selected data, you can make in a new data table. So this is the selected data from the previous scatter plot. They will make a new group, which is G1. It is based on the plot or the drag and drop that you just did. So this is just manually based on this linear regression. Maybe you're saying that I would like to choose the data which is closer to this line. Or we can have another ways, yeah, like the distribution. So in the distribution, you can also do with the data selection. So we can have this distribution of the data based on the width bin. Let's say I want to choose only the petal length, it is very low. So you can block this one, or you can choose. So I can choose with the shift function, press the shift, and then yeah, I want to do more analysis on this data only. Then you reduce the data into only those parts, and yeah, you can see that the item that you selected, it is using the condition, it is the factor length greater than or equal to 1 and factor length less than or equal to 2. So there are many ways to reduce the data based on this kind of condition. And we can also see with the data sampler. With the data sampler, you can go to make a new one, data sampler. We have data sampler, it is for the sampling. And there are several sampling approaches here. Whether you want to sampling with a fixed proportion of the data, or you have a fixed sample size. Let's say I want to choose one instance, or yeah, I can use the cross validation. So let me just skip the cross validation and bootstrap, because yeah, you can learn by yourself if you want. The fixed sample size. Let's say I want to choose 50. As you can see here, you can do with sample with replacement, or if you uncheck this one, it means sample without replacement. And you can also make the sampling replicable sampling, or you can also do with the stratified sample. So as I mentioned to you, we have the stratified sample. Because we are using the iris data, they have three flowers. They have three categories: iris setosa, iris versicolor, and iris virginica. So if we do the stratified sample, they will do with that class. So let's see if I want to reduce the data 50%. And then let's do it without stratified sample. If you look at this iris, we have a equal proportion. Iris setosa 50, iris versicolor 50, iris virginica 50. Okay. So the proportion is 33%, 33%, 32%. If you do with this data sampler, I want to check the distribution. As you can see now, if we do not use the stratified, I do not use stratified. So the proportion is 50. So we have this one is 31. Now it is 41.33%. This is 26.67%. This one is 32%. So the distribution is different. But if you want to use this stratified sample, if you do the sampling, then we will get the same distribution as the original data. So here the proportion is 33.3, 33.3, 33.3. and the data has been reduced into 50%. So each of them we have 25. Okay. Maybe for the sample with replacement, you cannot see clearly which data will be pre-selected. Okay? But if you need this one, yeah, you can use this function. Okay, so this is the explanation. Let me stop here.